Hi guys, I welcome you all to my channel CSNet Lectures. So in the last classes and all we discussed about Q data structures, isn't it? So what all its manual operations, what all its different types of algorithms and what all its conditions. So all those things we have covered. So in this session we are going to have a continuation of it. That is, we are going to discuss about its different types of problematic questions that you may get in the case of Q data structures. And I am going to tell you what are the important applications of Q data structures. Okay friends, shall we proceed for discussion? So before going into this discussion of this question, so you must have to know what is a Q data structure, right? Suppose if you don't know, that is a representation of Q data structure, that is how the elements are inserted and so on. You can just go and watch all the previous videos which I have given it in the description friends. So after watching that you can come for this problematic discussion. So you will be feeling it very easier for solving these type of questions. Okay friends, so now this is the given question. So the question is, if the first element of the queue is in the location 1 and the last element is in the location 4, then the total number of elements is what? So this is a question that is being asked. Okay friends, so now before going into the discussion, you must have to know how a Q data structure is represented. So for an example, I will draw this. So Q will be like this, isn't it? 1, 2, 3, 4 and so, so 1, 2, 3 and 4. So this is the representation of a Q data structure. We are having two pointers. So what is the use of those pointers? The front pointer is going to delete the elements from the queue and rear pointer is going to insert the element in the last position of the queue. Right. So let this be the front and this be the rear pointer. So now based on this question, the queue is having in the location 1. So let this be the location 1. So 0, 1, 2, 3. So this is the index used for representing the location of each and every elements. So actually we are having 4 elements present in the queue in the location 1, 2, 3 and 4. Isn't it? So now they have given that if the first element of the queue is in location 1. Suppose if the first element is in this location and the last element is in the 4th location. So this is the 4th position. Okay, for an instance they have given. Now you should have to find what is the total number of elements present in this Q data structure. Now can you tell me the answer? What will be the total number of elements present in the queue? So by seeing this diagram, you can able to tell that there are 4 elements present in the queue. Okay, so now there is a formula used for finding these type of questions. Suppose if they have given these values to be a larger number. So I am going to tell you what is the formula. So it is a very important formula. So you can use that formula for finding these type of questions. So this is the given formula friends. So this formula can be used if the pattern of the question is being asked in your examination. Okay, for the same type of question pattern you can use this formula. So the formula is rear minus front plus 1. Okay, so by substituting all the values that is being given in this question, you can able to determine what is the total number of elements that is being present in the queue. So they may ask the values directly or they may leave some of the values that is being present in the left hand side and you can make some substitution and you can determine any of the values. That is, you can find the rear position or you can find the total number of elements or you can find the front if the remaining values are being given. So like this you can use these formulas. So now shall we substitute the values that is being given in this question? Okay. So now if you see what is the rear value here. So the last element here tells you the rear value and the first tells you the front value, isn't it? So now what will be the rear value? So the rear value is 4 minus, so what is the front value? So the front value is given as 1. So substitute. So plus 1. So what will be your answer? Your answer is going to be 4. Okay, so by this you can directly substitute the formula and then you can find this answer. Okay friends, are you all clear with this type of problem? So by drawing this diagram also I can find, suppose if the size of the Q data structure is being given in a huge value. So how you will be substituting? So it is very difficult, isn't it? So for that purpose you can use this formula. Okay friends. Now we are going to discuss the next important point of a Q data structure, peak. So what is a peak? So peak is an inbuilt function of a Q data structure. So suppose if you give this name of Q, that is the name of the Q what we are going to use in the program. So it will give the result as the first element that is being present in this Q data structure. So peak is an inbuilt function of a Q data structure. So once if you have used in the program, so it is going to return the first element of the Q data structure. For an instant, I have drawn this Q data structure. So now if you see, the name of the Q is simply a Q variable. It is an array variable. So I have inserted some of the elements. So they are 55, 66, 70 and 10. For example, I am giving this. Okay, peak of Q. So what it will be retrieving? Can you please guess the answer? So the answer for this is, it is going to return the first element of the Q data structure. Okay, so here what is the first element? This or this? So the first element is the value which is being pointed to by the front pointer, isn't it? So it will return the answer as 55. Okay, so this is one of the important method. So you can just make a note of it. Okay, so they may ask in this type of a question. Okay friends, right. So friends, so that's all in this session. So in the next class, we are going to discuss some of the important problems of Q data structure. And also we are going to see its applications. Okay friends, thank you and bye.